Show by the principle of mathematical induction that for all n belonging to the set of natural numbers n, the expression 3 raised to the power of 2n, when we divide it by 8, the remainder is always 1. So here, what we have to do here is we do not have to show that 3 raised to the power of 2n when divided by 8 leaves us with a remainder of 1. Rather, we have to show here that any n, which is a natural number here, any n value that we take, this is always going to be a true statement. Okay, let us begin. So first what we'll do, we will suppose that let Pn be the mathematical statement which is given by 3 raised to the power of 2n when divided by 8, the remainder is always 1. So this is our statement. Fine. Now, to verify that this statement is true for all natural numbers, so first what we'll do, we will consider n to be equals to 1. That means we'll consider the first natural number 1. Then the statement p of 1 will become 3 raised to the power of 2. So we have 3 squared, which is equals to 9. And we know when we divide 9 by 8, the remainder is always 1. This simply means that the statement p of 1 is true. However, we'll also have to verify that it is true for other natural numbers. So here what we'll do, we will suppose that the statement p of m is true. Now what is the statement p of m? The statement p of m is such that we have 3 raised to the power of 2 times m. So we are replacing n with m. Everything else remains the same. So the 3 raised to the power of 2m when divided by 8, the remainder is always 1. And using this statement, our goal will be to verify that p of m plus 1 is also a true statement. Now what is p of m plus 1? So let's try to understand p of m plus 1. So p of m plus 1 will be simply 3 raised to the power of 2 times m plus 1. So this is going to be the expression, and when we divide it by 8, also leaves the remainder as 1. The remainder is 1. So this is our goal. Our goal will be to verify that the expression 3 raised to the power of 2 times m plus 1 when divided by 8 also leaves a remainder of 1. So how shall we show that? Now since we have already considered 3 raised to the power of 2m when divided by 8, the remainder is 1 to be a true statement. That means pm is a true statement. So we can use this fact. Since pm is true, so we have here 3 raised to the power of 2m. So this can be expressed as 8 times lambda plus 1. Right. So we are going to use this fact. And now what we have is 3 raised to the power of 2 times m plus 1. So what we do, we're going to rewrite this expression as 3 raised to the power of 2m added to 2. Now 3 raised to the power of 2m added to 2, that's simply 3 raised to the power of 2m added to 3 square. We're using the law of exponents here. Now 3 raised to the power of 2m, now 3 square, let's write it first, that's 9. Multiply it to 3 raised to the power of 2m. But what we can do, we can replace it with 8 times lambda plus 1. Fine. So this is going to be equals to 9 multiplied to 8 lambda added to 9 times 1. So that's 9. So this is going to be equals to 9 times 8 lambda. But we are going to split 9 into 2 portions as 8 added to 1. 8 plus 1. So that when we take 8 as the common factor from the first term and the second term, we have 8 multiplied to 9 times lambda added to 1 plus 1. So here, we can replace 9 times lambda plus 1 with a constant beta, where beta equals to, we don't have to worry about the value of beta. So beta equals to 9 times lambda plus 1. But in doing so, we were able to successfully show that 3 raised to the power of 2m plus 1. So when we divide it by 8, it always leaves us a remainder of 1. So this simply tells us that the statement p of m plus 1 is also a true statement. So if p of m plus 1 is a true statement, hence we can generalize it and finally say that the original statement p of n is to a true statement. This is going to be a true statement for all values of n belonging to the set of natural numbers. That means any natural number that we take, we can take m, we can take m plus 1, we can take 1, 2, 3, any natural number that we take, the statement p of n, which is given by 3 raised to the power of 2n when divided by 8, the remainder is always 1. This is always going to be a true statement, hence proved.